Hey guys, welcome to Simply Electrical. This is part of my deep dive series where I'm going to walk you through a very detailed breakdown of a single family dwelling service calculation using the optional method. We're going to be in the 2020 code, but take my word for it, this is going to be good for most code cycles going back at least 3 or 4. They don't change much cycle to cycle in Article 220, especially 220.82, which is what we'll be dealing with in this video. Now you're going to find out that this optional method, when compared to the standard method, is very easy, very straightforward, and quite linear, and it's just much quicker to compute compared to the standard method. I put together this table in an attempt to make it really easy for you to see the whole picture. I wanted to have the whole calculation in one shot, so you don't have to be flipping back and forth with pages of notes and information. You can see how everything ties together. And you can use this as a worksheet or a template or whatever you want to do, whether you're taking a test for like a state exam or maybe you're using this for a real world situation. So I'll give you a quick overview of how this chart is laid out, and then we'll take an example and we'll work our way through an example and go to the code book, to each code reference, and figure out exactly where the information comes from and how to apply it and come up with an accurate answer. So we're going to start over here in this left column. It says miscellaneous loads. We're going to take our square footage of our occupancy, which in this case is a single family dwelling, to get our VA load. And we're going to take our small appliances and our laundry and then all of our fixed appliances. We're going to take range, dryer, water heater, extra motors, everything at nameplate here. We're going to come up with a subtotal. We're going to transfer that figure up here. We're going to take our demand factor and get a miscellaneous total. After we've got that, we're going to take our heat and cooling and find out which is the largest, and it's not quite that simple. There are some provisions that we got to take into account, but I have a little note here that says heat at 65% with a question mark, because by far that's the most common way you're going to use this part of the table, is you're going to be taking your heat at 65%, and we'll explain that when we get into it. But anyway, you're going to get your total for your heat and cooling and your miscellaneous total, add them together, get your total VA for the entire dwelling. You're going to divide by your voltage to come up with your amps. And that's how you size your service, your feeders, your conduit, all that stuff. Okay, let's get to our example. So we have a 1900 square foot house, has 1300 watt dishwasher, a 4500 watt water heater, an 1100 watt disposal, a 10,000 watt range, 4800 watt dryer, 12 kW furnace, and a 6500 watt heat pump. The service from the street is 120 240 volt single phase. So what is the total calculated service load in amps? All right, so first of all, we're going to talk about part 4, which is the optional feeder and service load calculations. That's where you go in the code book to do an optional method calculation for a single family dwelling. 220.80 says general optional feeder and service load calculations shall be permitted in accordance with part 4. This is part 4. Now there are some stipulations on when you can and cannot use the optional method of calculation, and we'll read about that right here in 220.82a. So it says dwelling unit, feeder and service load. This section applies to a dwelling unit having the total connected load served by a single 120 240 volt or 208Y 120 volt set of 3-wire service or feeder conductors with an ampacity of 100 or greater. Okay, so that's telling you that this is the only time you can use the optional method. It's got to be 100 amps or greater, first of all, and it's got to be these voltages. It's got to be a single 120 240 volt or 208Y 120 volt set of 3-wire service or feeder conductors. And that's it. If you have anything outside of that, you cannot use the optional method. So that's important because some people don't remember that when they go to use the optional method. Now, granted, that is like the most common situation you're going to have, especially in a single family dwelling. So in most cases it does apply. But just keep that in mind that there are some stipulations. Next sentence says, it shall be permissible to calculate the feeder and service loads in accordance with this section instead of the method specified in Part 3 of this article. So Part 3 of this article, of Article 220, Part 3 is the standard method. So it's telling you this is a legitimate way that you can use to make the calculation in lieu of the standard method. Next sentence says, the calculated load shall be the result of adding the loads from 220.82b and c. We'll come back to that in just a bit. Feeder and service entrance conductors whose calculated load is determined by this optional calculation shall be permitted to have the neutral load determined by 220.61. Okay, we won't be discussing the neutral load calculation in this video. I will have another video that goes over neutral load calculation for all services. Okay, moving on down. Section B, we have general loads. The general calculated load shall be not less than 100% of the first 10 kVA plus 40% of the remainder of the following loads. Okay, so the following loads, we're going to go over those first, and then we're going to come back to find out how we're going to apply this to those loads. Number 1, 3 volt amperes per square foot for general lighting and general use receptacles. Okay, so just like the standard method, we're going to take the square footage of our house and we're going to multiply by 3. You get 3 volt amps for every square foot. So over here we have our square footage times 3, and ours happens to be 1900 square feet for the house. Notice we have our example written down here, all of our data from our example. 1900 times 3 is 5700 VA. And it gives you the code reference, 220.82b1. That's where we get that. It goes on to say, the floor area of each floor shall be calculated from the outside dimensions of the dwelling unit. The calculated floor area shall not include open porches, garages, or unused or unfinished spaces not adaptable for future use. All right, so that's pretty straightforward. Next load says number 2, 1500 volt amps for each 2-wire 20 amp small appliance branch circuit and each laundry branch circuit covered in 210.11 C1 and C2. Well, what does that say? Go over here to 210.11 C1 and 2. Dwelling units, small appliance branch circuits. So in addition to the number of branch circuits required by other parts of this section, 2 or more 20 amp small appliance branch circuits shall be provided for all reciprocal outlets specified by 210.52b. 210.52b just tells you that it's basically kitchen receptacles and any room that's directly related to a kitchen, like a dining room, a pantry, a breakfast room, stuff like that. So any of those receptacle outlets will be included in this calculation. Now there is an exception to that, and I go over that in great depth in our single family dwelling standard calculation. So please reference my video for that if you need more information on exactly what those requirements are. Part 2, laundry branch circuits. In addition to the number of branch circuits required by other parts of this section, at least one additional 20 amp branch circuit is provided to supply the laundry receptacle outlets required by 210.52f. And this circuit shall have no other outlets. Okay, so that's just your basic laundry branch circuit. You're required to have one. So we have 2 small appliance circuits required and 1 laundry branch circuit required. So that's what we have right over here. Small appliances, 1500 watts each times 2 minimum. Laundry, 1500 each times 1 minimum. So you have your VA here, 3000 minimum here, 1500 minimum here. And in our example, it doesn't tell us anything about laundry loads, it doesn't tell us about small appliance circuits, so we have to remember to add those in on our own, because those are a must. That's what this is telling us, they are required in every house. So just a quick recap where we get our numbers. We need 1500 volt amps for each 2-wire 20 amp small appliance and laundry circuit. So we have 15 for each. Okay, moving on to our fixed appliances. Let's see down here, number 3 says the nameplate rating of the following. A, all appliances that are fastened in place, permanently connected, or located to be on a specific circuit. All right, so that's what we have here, fixed appliances. We're going to take the nameplate of all these appliances, and there's our code reference, 220.82b3a. In this case, we have dishwasher and disposal. Here's a dishwasher, here's a disposal, and we have 1300 watts or VA, 1100 VA. We have them listed right there. Now you may have 3 or 4 or 5 or 6, or you may have 10 of these appliances or more. So you just got to list them all here and add them all up. And we're taking nameplate ratings of everything. Okay, next. Under B says ranges, wall-mounted ovens, counter-mounted cooking units. So we have our ranges here, nameplate 220.82B3B, and we have a 10,000 watt range, so we just stick 10,000 right there. You don't go to the range table, you don't go anywhere, you just put the nameplate value here. Okay, next, C, we got clothes dryers that are not connected to the laundry branch circuit specified in item 2. So you got your dryer, nameplate, 4,800 watts right there. 4,800 watt dryer, just put 4,800. Again, we do not go to the dryer table and take any kind of demand factor. We just take the nameplate. And it says only dryers that are not connected to the laundry branch circuit specified in item 2. Item 2, of course, is the laundry branch circuit we already talked about. Now this is just basically talking about, this is only for an electric clothes dryer. If you had a gas dryer, a lot of times a gas dryer will plug into the laundry branch circuit for the washer as well. So that, if that's the case, you wouldn't include it here. It's included there already. So this is just electric clothes dryers. Okay, next is D, water heaters. So we got water heater, nameplate rating, 4,500, because we have a 4,500 watt water heater. Last of all, it says the nameplate rating of all permanently connected motors not included in item 3. So any motors that aren't included in item 3, so anything that's a motor that's not in all of this, you have to put it here. That way you're taking care of every load in the house. So they're covering all their bases here. Once you have that number, you add all these loads together straight up, and you come up with 31,900 VA for your miscellaneous subtotal. Okay, now we're going to take that subtotal down here and just transfer that number right up to here, 31,900. That's your subtotal from the first column. Now we're going to get into our demand factors. And remember, I told you we're going to be coming back to this phrase in 220.82b. We already read this once. It says, general loads. The general calculated load shall be not less than 100% of the first 10 kVA plus 40% of the remainder of the following loads. So the following loads were all these loads over here that we added up. So we take the first 10,000 at 100%. So we'll just write 10,000 there. So that leaves us with 21,900. So the remainder we take 40% of. So 40% of 21,900 is 8,760. Then we just add the 10,000 back in, and we get 18,760 VA for our miscellaneous total. Okay, last section is the heating and cooling. Let's read through 220.82c. It says heating and air conditioning load. The largest of the following 6 selections, load in kVA, shall be included. 1, 2, 3, 4, 5, 6. So the largest of these 6 shall be included. Number 1, 100% of the nameplate rating or ratings of the air conditioning and cooling. Number 2, 100% of the nameplate rating or ratings of the heat pump when the heat pump is used without any supplemental electric heating. So this would be for a system that does not have any supplemental heat strips, like a furnace, say. And it's just using the heat pump solely for both heating and cooling. An example of this might be a mini split system. Number 3 says 100% of the nameplate rating or ratings of the heat pump compressor and 65% of the supplemental electric heating for central electric space heating systems. Now this is your typical furnace, say, air handler with a heat pump. And it says if the heat pump compressor is prevented from operating at the same time as the supplementary heat, it does not need to be added to the supplementary heat for the total central space heating load. So if you have a non-coincident load set up here, where your heating and your AC are prevented from being used at the same time, then you don't take the heat pump compressor motor load. You only take the 65% of the heat. Now what makes this easy to remember is number 4 here. It says you take 65% of the nameplate rating or ratings of electric space heating if less than 4 separately controlled units. So if you only have a furnace, let's say, air handler, and you have, one thermostat or maybe 2 thermostats most, you will use 65% of it, the same number that we'd use here. So whether you have a heat pump that's prevented from being operated at the same time, or you don't have a heat pump at all, either way you're going to be taking 65% of your heating load. Okay, number 5, take 40% of the nameplate rating or ratings of electric space heating if 4 or more separately controlled units. So if you have wall heaters maybe, or baseboard heaters, or maybe ceiling heat, and you have 4 or more separate thermostats, then you would use 40% of your total. And then lastly, number 6 says 100% of the nameplate ratings of electric thermal storage and other heating systems where the usual load is expected to be continuous at the full nameplate value. Systems qualifying under this section shall not be calculated under any other selection in 220.82c. So if you have a heating system that does not fall under 1, 2, 3, 4, or 5 and is usually going to be running at continuous full nameplate value, you've got to take it at 100%. Okay, so where do we fall? We have a 12,000 kW furnace and a 6,500 watt heat pump. So 12 kW furnace, this is going to fall under number 3 because we have a furnace which gives us our supplementary heat, and we have a heat pump. And so we're going to take the 65% because they're not going to be running at the same time. So we take 12,000 of our heat times 65%, and we come up with a heating and cooling total of 7,800 VA. Okay, now that we have our miscellaneous total and our heating and cooling total, we're going to go back and read this section again back in 220.82a. I told you we'd be coming back to this. It says the calculated load shall be the result of adding the loads from 220.82b and c. 220.82b, that is this total, and 220.82c is this total. So we just add those two together. We come up with a total VA of 26,560 VA for the entire single family dwelling. And we know that 240 volt single phase is our voltage, so we just divide by 240 and we get 111 amps. And that is our service size. Okay, here is the template one more time. I took out most of the color so that you guys could take a screenshot, maybe make some copies of it, use it as a worksheet or a template or however you want to use it. I just wanted you to be able to make a quick calculation whenever you needed to. Just fill in your own numbers and you should be able to come up with the right answer really quickly anytime you need it. Thanks so much for watching, guys. If you like this, please give it a like and subscribe to my channel if you think you'd like to see more of this kind of content. Please check out my other videos. I have a crash course series also that just goes through several different examples to try to give you an idea of what you might run into either on a test or in a real-world situation. And I go through it much more quickly, and I don't go into a lot of detail because that's what this video was for. And then I also have other videos on other calculations. So please check out my channel, check out my other videos, and let me know in the comments what you might want to see in the future, if there are any other kind of calculation videos or any other things related to electrical, and I'll see what I can do about making a video of it. All right. Well, thanks, guys, and don't forget, always stay free.